Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as rainfall runoff relationship. So rainfall and runoff is two things, both are related to each other. So whenever the rainfall occurs, how the runoff is affected or how the runoff is impacted or how the runoff is related to the rainfall based on the different factors here we will just understand today. So whenever the rainfall occurs, there are different factors which will influence this rainfall runoff or any kind of runoff will be affected or impacted. So based on that we can just identify whether that area is slope area or the plain area. So if runoff is more, that means the area is the sloping area, and if runoff is less, that means the area is the plain area. As well as based on the soil type, we can just identify about this rainfall runoff. So let us start the lecture today. So this is the contents we are going to discuss today: rainfall runoff relationship, rainfall characteristics, factors affecting, influencing the relationship, mathematical models, observations and data collections. So first of all, let us understand what is the rainfall runoff relationships. Okay, so the relationship between rainfall and runoff, it's a fundamental concept in the hydrology. So it's a hydrology concept, fundamental concept in hydrology. So relationship between rainfall and runoff. What is the relationship between rainfall and runoff? Rainfall is like the precipitation due to the presence of evaporation. When the water evaporates and when then it goes to the environment, when it goes to the atmosphere, it forms a cloud and it comes in the form of the precipitation and falls on the ground. So when it falls on the ground, there are different factors which affect this rainfall runoff. So for example, this is the rainfall is happening. When it is falling on the ground, there are many kind of terrain here. So here we have a terrain like this. We have hills, we have slopes, we have plateaus. So based on this, whether it will fall, the flow will be fast, either the flow will be slow. Based on that, it will be decided. So it is a fundamental concept of in hydrology. So this relationship describes how rainfall translates into runoff. So this will describe the relationship how the rainfall translates into runoff, which is the portion of the rainfall. So that flows over the land surface and eventually reaches the river, lakes and other bodies. So how is the process? The process will be followed. So for example, we have here we have the source of water. Okay, source of water. So what is the source of water here? So evaporation will take place like this. Evaporation will be taking place. So you can see evaporation, and here it will form cloud here. Okay, and then it will come down again in the form of rainfall. Okay, rainfall in the form of rainfall, where you have hills and you have land, slopey areas. So it will fall like this and it will flow, eventually reaches to the rivers and lake. Again it goes and reaches to the lake. Suppose this is a river or lake. So it reaches to the river or lake. So where it will reaches to the river or lake of the water body. Now the rainfall characteristics. So what are the different characteristics? So precipitation in the arid and semi-arid zones results largely from the convective cloud mechanisms, producing storms typically of short duration, relatively high intensity and limited aerial extent. So what are the different characteristics here of rainfall? So if you talk about the different characteristics of the rainfall in the semi-arid zones, the rainfall will be not much effective. The rainfall will be average, and in the arid zone the rainfall is very low, whereas in the zones like evergreen zones, like wherever the forests are more, the rainfall is more high over there. So semi-arid zones results largely from the convective and cloud mechanisms producing the storms, and in semi-arid zones you will see that the storms are produced and the cloud mechanisms are producing, typically of short duration, relatively high intensity and the limited area extent. However, low intensity frontal type rains are also experienced. We can see in this such kind of semi-arid zones, you can see there will be a low intensity of the rain and frontal type rains will occur, and also experience usually in the winter season also. So in the winter season also you will be seeing that low intensity rain will be there with the frontal type of rains with storms, and typically with a short duration this kind of rains will occur in the semi-arid zones. So when most precipitation occurs during the winter as relatively low intensity rainfall. When the precipitation occurs in the winter season, the intensity of the rainfall will be very less, and it may represent the greater part of the annual rainfall. So low intensity means less rainfall will be there. With the low intensity means the flow will be high. Runoff will not be there. Most of the water will be seeped inside the ground. If the high intensity is there, then only the runoff will be more. Now, rainfall intensity is defined as the ratio of the total amount of rainfall. So, how the rainfall intensity is defined? It is the ratio of the total amount of rainfall. Suppose total rainfall is per day, if you tell about 10 centimeters or 20 centimeters, so it is total amount of the rainfall. The ratio of that is called as rainfall intensity, falling due to the given period to the duration of the period. So it is expressed in the depth units per unit time. So always the rainfall intensity, it is expressed in the depths units per unit time, usually as mm per hour. So rainfall is usually for like mm per hour, it is usually expressed. And the statistical characteristics of the high intensity, short duration, convective rainfall are essentially independent of locations within a region and are similar in many parts of the world. So statistically characteristics of the high intensity, it has a short duration, it has a convective rainfall, and essentially it is independent of locations within a region and are similar in many parts of the world. Analysis of the short-term rainfall data suggests that there is a reasonably stable relationships governing the intensity characteristics of this type of rainfall. So analysis says that short-term rainfall data suggests that there is a reasonably stable relationship governing the intensity characteristics of this type of rainfall. Now, we have several factors which influence the relationship. So, what are the several factors which influence the rainfall relationships here? So, rainfall intensity is the first factor which will influence the rainfall relationship, rainfall intensity and duration. So, high intensity rainfall events or long duration rains are more likely to produce significant runoff. High intensity compared to the light or short duration rainfall events. Now, comparatively, if there is a high intensity of the rainfall means if rainfall is continuously falling for half an hour, for 30 minutes, continuous rainfall, okay, continuous rainfall with high intensity, continuous rainfall with high intensity. In that case, what will happen? The runoff will be more. It will produce the runoff will be more and compared to the light and short duration rainfall. So wherever the short duration rainfall will be there, the runoff will be less because the staying of the water will be not there. So immediately when the water falls, it will flow off. So for example, if you throw the water with a full force, it will be just simply it will flow. The runoff will be there of that water. If you pour the water very slowly, the runoff will be very slow and the seepage will take place. So this is what happens wherever such areas like it has a high intensity rainfall with a more duration, that such kind of rainfall with a more duration, the runoff will be more. So most of the areas where the forest is not present, in such areas the soil erosion will happen and there is no point of there is no facility of holding the water there. So if the rain is continuous for 30 minutes with a high intensity, so a lot of runoff will be there. So top layer of the soil will be totally washed away based on this runoff conditions. So once the total area is washed away, the top layer is washed away, soil erosion will take place. So this is the main factor here. So when the runoff is more, when the intensity is high intensity with a more duration, the runoff is more always. So when the low intensity with a short time period, the runoff is less always. So this is how we see, this is the main factor here. Next thing what we can see here is soil characteristics. So what are the soil characteristics here? So type of the soil also will define the character of the rainfall, will define whether water is going to be seeped inside the ground or the water is going to flow off or the presence of water should be maintained like that. So that all comes under the soil characteristics. So the type, structure and moisture content of the soil affects its infiltration capacity. How do it affects its infiltration capacity here? So if the structure of the soil, is sandy, so sandy soil typically have higher infiltration. Now, if you have like in such places like areas wherever the sandy soil is present and the rainfall is even though high intensity, it is having the capacity of holding the water because it is having very high infiltration rate. Immediately, the water will be infiltrated inside the soil. So wherever such areas will be having the sandy kind of soil, the filtration rate is more. So immediately the water will be enter into the as and it will converted into the groundwater, right? Than the clay soil. Clay soil is having very less infiltration condition. So clay soil, what happens when the water flows, when the water is falling on the ground? So clay soil will not absorb the water. It will just the runoff is more. So wherever you find the clay soils, in areas wherever you find the clay soil, so the runoff conditions are more. There the water retention won't be there. Immediately once you pour the water, when the rainfall occurs, most of the 90% of the water is flowed away, washed away. So the runoff condition is more in the such areas wherever the clay type of soil is available, which means less runoff, and it is having more less infiltration rates. Now, if you talk about the land use and land cover, so land use and land cover is also one of the factor here. So urban areas with impervious surface like roads and roofs generate more runoff compared to the rural areas with a natural vegetation which can absorb more water. So urban areas with impervious surfaces like roads, roofs, and it will generate more runoff compared to the rural areas and with natural vegetation which can absorb more water. So urban areas which is having the impervious layers, like if you create the roads in the urban areas like which is having the impervious surface, which is having the capacity of absorbing the water, so the runoff will be less. So that kind of impervious pavements, if we lay in such kind of areas in the urban areas, it will help us to reduce the runoff there. So generate more runoff compared to the rural areas, and natural vegetation which can absorb the more water. Wherever the natural vegetation is present, it will just absorb the more water, it will absorb the more water. Whereas in the areas wherever the the forest boundary is not there, the forest is not present, more number of buildings are there, the runoff will be more because the water cannot hold because of the presence of the structures, concrete structures where the water cannot hold. The runoff is more in such areas. So land use or land cover is also one of the most important factor here. Based on that, the runoff will either more, and the runoff based on that, maybe the runoff will be less. Now topography. So what is the type of the topography? Now steeper slopes promote faster runoff. Steeper slopes promote the faster runoff. As I said, steeper slope means if you have a slope like this, very steep slope. So whenever the rain occurs here, it will directly go as a runoff. So runoff will occur like this. So this is the runoff way. Directly the runoff will occur more. Okay, runoff will occur more. Okay, so steeper the slope, runoff is more. While flat areas allow more water to infiltrate wherever you have a flat area. So it will allow you to infiltrate the water, because flat areas, whenever the rainfall will occur. So if the flat surface is there, what will happen? The water will be retained. So retention of the water will be there. Retention of the water. So here on the flat areas, the retention of the water will be there. Wherever the steeper slopes will be there, the runoff is more, and allow more water to infiltrate into the soil. So this is more important here. First of all, when you talk about this factors which affects the runoff, so steeper the slope, the runoff is more. Flat the surface, runoff is less, and infiltration is always high here in the flat surfaces, whereas infiltration is low in the infiltration is low in the steeper slopes. Okay. Now vegetation. Areas with dense vegetation can intercept rainfall, reducing the amount reaching the ground and promoting the infiltration. So areas which are having dense vegetation, which will help us to just try to hold the water, whereas wherever the vegetation is there, it will not hold the water, it will reduce the amount of reaching to the ground, promoting the infiltration, thus reducing the runoff. Now antecedent moisture conditions. So the moisture conditions content of the soil prior to the rainfall event affects its ability to absorb the water. Saturated soils produce more runoff than the dry soils. So the saturated soils will produce more runoff than the dry soils. And now if you see the mathematical models here, several models are used to quantify the rainfall runoff relationship. So we have different models here which will quantify the rainfall and runoff relationship here. So first thing, we have a rational method. So this is the simplest method which will estimate the peak and runoff rates using the formula. So the formula here we use here is Q is equal to CIA. So where Q is the peak runoff rate, where C is the runoff coefficient, now where I is the rainfall intensity, and where A is the drainage area. So this is the formula we use for this rational method. Now SCS curve number method we have here. So developed by the soil conservation, this SCS curve method was developed by the soil conservation service, and this method uses the curve number to estimate the direct runoff. So this method is used for estimating the direct runoff of any rainfall areas wherever the rainfall is going to occur. So CN is determined based on the land use, soil type, and antecedent moisture condition, and the relationship is given by Q is equal to P minus 0.2s by P plus 0.8s. Okay, so where P is the total rainfall and S is the potential maximum retention after the runoff begins. Now it is calculated as S is equal to 1000 by Cn minus 10. Now hydrological simulation models, if we talk about this model, so it is the advanced models like SWAT. SWAT we have, it's a hydrological model which has a soil and water assessment tool which will help us to find out the rainfall and runoff conditions with the help of, once you input the rainfall data and runoff data, it will give you the output runoff and rainfall data, that what is the condition of that area. It will tell you the condition of the soil and it will tell you the condition of the water. So HEC and HMS, Hydrologic Engineering Center, Hydrologic Modeling System, and others. It will simulate the rainfall runoff process considering the various hydrological process and the spatial variability. Now SWAT. Let us see what is a SWAT. SWAT is a physically based continuous model. It's a physically based continuous model, and it is efficient for the users to study the long-term impacts. So SWAT operates on the daily time step at the basin scale with ARC or ArcView, or GIS interface, which is developed to predict the impact on the land use and the land cover. And it will give the parameters like runoff and evapotranspiration, potential evapotranspiration of the large areas, and completely and uniformly covered with growing vegetation and an unlimited supply of the soil water it will give us. So SWAT is a physically based, it is a tool where it will show you the soil and water condition, and it will tell you about the soil condition and the water condition of that area. To achieve this, rainfall and runoff models are widely employed as the valuable tools in the watershed management. To achieve this rainfall and runoff conditions, we can use this SWAT model for any watershed conditions, which will tell you about the water condition as well as the soil conditions. So for this specific study, two modeling approaches were employed: the soil and water assessment tool model and set of 8 artificial intelligence models. It will help us to tell us about the soil and water conditions. Now empirical observations, if you see, empirical observations often show a non-linear relationships between rainfall and runoff. It shows the non-linear relationships between the rainfall and runoff due to the complex interplay of the factors mentioned below. So observation and data collections, in the observations and data collections, we can see from watershed helps in the refining models and improving the predictions of runoff of different rainfall events. Understanding the rainfall runoff relationship is essential for effective water resource management. It will understand the rainfall relationship, and it is essential for the effective water resource management. It will help us in the flood forecasting and designing the hydraulic structures like dams, culverts, and drainage systems. So observations here we can see it will help in refining the models and improving the predictions of runoff in the different rainfalls events. We can understand the rainfall runoff relationships, and we can just use the essential for effective water resource management. And flood forecasting and designing, it will help to design the hydraulic structures, like it will help us to design the like dams, culverts, and drainage. Because once you know the rainfall runoff relationship, that how much rainfall is going to occur in such area and how much runoff is there in such area, then we are able to find out the total amount of rainfall which is going to occur over there, and what are the problems we are going to face, whether such areas is going to be flooded or not. That all we are going to analysis, and finally we can just come to our conclusion that whether to construct a dam or whether to construct a culvert or whether to construct a drainage system in such areas. So this is rainfall relationship is very much important in this designing purpose and converting the structures and maintaining the structures, and it will help us to flood forecasting, even it will help us to understand the essential effective water resource management also, how much water is going to be stored or how much water is going to be run off. We can use such mathematical models, we can use such tools to find out the type of the soil, and we can use to find out the type quantity of the water present on that surface area. So these are the few references which you can just go through to find out the more content about it. Like I mentioned, a book from Remote Sensing GIS by BS publication, you can just go through. You can go through these links to find out the more content about it, and you can just get to know about this rainfall and runoff relationship about this topic. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.